Hello, welcome to a very short presentation explaining work in physics. If you're asked to do work on a building site, it's likely you'd be asked to carry stuff to the top floor of a set of flats. So let's say we ask this guy to take this 20 kilogram block of materials up the 4 flights. Now, if we were feeling generous, we might pay him £80 for that, let's say, okay, which is pretty decent income for this guy. So, to be fair, how much should we pay this guy? He's only going to go up 2 flights of stairs, but he's going to carry twice the weight, right? So hopefully you realise that this guy going 2 flights, but he's carrying twice as much, so it's basically the same, okay? So if you're paying this guy £80, you should also pay this guy £80. Now there's an interesting pattern that pops up. The 4 times 20 is the same as 80, and the 2 times the total mass here is also 80. So that's very similar to how we think of it in physics. If you think of work in physics quite literally as being like physical work that you'd pay for and pay for in pounds, it really helps to sort of put into context what it means, what work means. In fact, that's how and why people really came up with the concept of work and energy and joules in the first place, because we're thinking about buying coal to run a steam engine, for instance. Okay, so let's say we have another day and these guys want to earn some money again. This guy puts 80 kilograms on his back and lies at the bottom of the flat and achieves nothing. Okay, are you going to pay him? Well, you might feel sorry for him, but he's not done any work for you, so you probably wouldn't pay him. So technically he hasn't done any work either. Okay, whereas this guy who's climbed 2 flights of stairs with 20 kilograms on his back, if we pay him the same rate as yesterday, we'd pay him £40. Alright, so now let's have a look at the equation for work in physics. Okay, so work is defined as the product or the multiplication of force multiplied by the distance over which the force is applied. Okay, right, so if you go back a second, that's why this guy wouldn't have been paid, or he didn't do any work, because he didn't move any distance. Okay, so in the equation, force multiplied by distance, force is in newtons, distance is in meters, right? So you need to stick to your standard units. And work, you could give it the unit Newton meters, but as that unit is also used for torque, or it looks like the same unit as torque, we give it a different unit, which is joules, named after the guy who came up with it. So that basically avoids some confusion. So small j, or joules. Right, it's also pretty convenient to think of force on a graph. Okay, force and distance on a graph. So if you imagine somebody has pushed a block, right, with a force of 10 newtons. So you've got a guy here with very long arms pushing this block, and he applies a force of 10 newtons. Oh, I've already put 10 newtons. And he moves it through a certain distance. Let's say that distance is 15 meters. Yes, we can see that if I just apply the formula, work will be equal to force times distance. So that will be equal to 10 times 15. So he's done 150. Gosh. He's done 150 joules of work. Right? But it's actually quite convenient to sometimes look at these things on a graph, and you'll certainly see that later on as we go into other areas where energy and work are discussed. So if you plot force on a graph here in newtons, and displacement or distance here, right, for this you'd have seen a graph that was 10 newtons high, and it would have been moved 15 meters, and it's quite useful to think about this as an area that represents the work done. Okay, and that will come up when we look at springs and gravitational potential energy and other areas. Okay, I hope you've found this short introduction to work useful, and if you have any comments, questions or corrections, please make them in the comments.